Jai Hind all of you. Myself Nishu Bansal from CSC department AKGEC college. So now the next topic for the DBMS, it's in the important topics, that is the enhanced entity relationship, that is EER concepts that we will cover in today's lecture. So let's start. So these are the outline that we will be covering today. That is, first let's see what is EER. This is enhanced ER or extended ER. Before this, the main thing that we need to know is that at the conceptual level, it's the ER diagrams that is being made by the database designers, so as to make the client understand what is the requirement for them and what all would be the entities and the relationships that would be there in the database for their company. So enhanced ER or extended ER, basically it's an extension that it would be covering various concepts, advanced concepts of the object oriented in this, and here we have brought into the subclass and superclass concepts also. So ER model concepts, it includes all the modeling concepts of the basic ER, that is what all the ER was able to cover, that is also covered in the extended ER. Concepts such as the various entities and the relationships among them. Then the cardinality ratio is there in this also, plus the constant on the minimum that should be the relationship between the two entities, that is also being covered in this. In addition to that, we have the concepts of superclass, subclass concepts that can be represented in the EER. Then specialization, generalization we will see. Then a new concept, that is the union type categories, we will also look into this. Then attribute and relationship inheritance, that is how the inheritance is being done in the entity relationships. Then finally we will look at a new term, that is the aggregation. First let's see the subclass and the superclass concept. An entity type may have additional meaningful subgroupings. So basically the ER diagrams, they are not representing a single entity, they are representing basically the entity types. That is, here the entity type is nothing but this particular, here the concept is, it is basically the class, we can say over here. So it may have some additional meaningful subgroups of its entities. For example, if we have a class for say, or an entity type, that is employee, it may be further grouped into secretary, engineer, technicians, like this, based upon the employee's job. Like in any organization, people are not on a single profile, they may be working, they may be having different profiles. So depending upon the job profile, the employees can be further categorized. Then we can have managers, these are the employees who are the managers. Then next entity type can be the salaried employees and the hourly employees. Salaried employees, first say people are getting the wages based upon on the monthly basis. Then hourly employee, people who are getting wages depending upon the number of hours they are working in a day. So it's a method of, based upon the method of payment. So extended EER diagrams, they extend the ER diagrams to represent these additional subgroupings. These subgroupings are said to be the subclasses or the subtypes. So here's a representation of this particular subgrouping, that is the subclass and the superclass concepts. Let's see, here employee, we can say this is the superclass. So these are the various attributes of the employee type. Then see, based upon one of the specialization, that is a job profile. Here based upon job profile, we have categorized them into secretary, technician, engineer. Now they may be having their own specialized attributes. Secretary can be having the typing speed, it is a special attribute for the secretary. Then technicians, they may be having technician grade. Then engineers, they may be having the engineer type. Then managers, they may be having further, if we look at here, this is what we got from the ER. So here manager manages the project. Then based upon the method of payment, we have the salaried employees and the hourly employees. Salaried employees, they may be having salary as their specialized attribute, and hourly employees, they have pay scale, that is what wages they are getting on the hourly basis. Then further they have a relationship with another entity type, that is a trade union, that is people may be belonging to the different trade unions within the organization. Now each of these subgrouping is a subset of the employee entity, and each is called a subclass of the employee. Employee is the superclass for each of these subclass. So now how we read this? These are called the superclass subclass relationships. So employee secretary, that is employee is a superclass, secretary is a subclass. So this is how the representation is being done. Likewise, employee technician, employee manager. Now this is very important to understand this concept, because while we are making the extended EER diagrams, the people may not be able to categorize into subclasses. So we have to very carefully understand how these superclasses can be categorized into subclasses, so that we get a proper EER diagrams. So superclass subclass relationship is called a relationship. So secretary is a employee, technician is a employee. So here is the subclass, here we have is the superclass. So subclass is a type of superclass. Note, an entity that is a member of a subclass represents the same real world entity as some member of the superclass. Let's discuss this particular thing, like any member of the subclass would also be the member of the superclass, but it's not necessary vice versa. That is, it's not necessary that every member of the superclass belongs to some of the classes of the subclasses. So, but at the bottom level, we can have only those members which belong to the upper level. The subclass member is the same entity in a distinct specific role. The only idea is we want them to have different roles at the sub level. An entity cannot exist in the database merely by being a member of the subclass. It should be the member of the superclass. So superclass is like a big category, and we have further small categories or subdivisions. A member of the superclass can be optionally included as a member of any of its subclasses. So it's not necessary that all the members of the superclass belongs to the subclass. Let's take an example. A salaried employee who is also an engineer belongs to two subclasses for say. Now see, if a person is on a job profile, but obviously he would be getting some salary. So the person is like an engineer also, plus a person is if getting salary on the monthly basis, would be a salaried employee. So they would be belonging to both of these subclasses as we have seen in this particular diagram. So an engineer and a salaried employee. A person belonging to any of these category would belong to salaried employee or hourly employee. So they may be belonging to more than 2 subclasses. A salaried employee who is also an engineering manager belongs to 3 subclasses: manager, engineer, salaried employee. So we may be having a person who is a manager also, who is an engineer, plus a person who is getting the salaried. So a person can belong to more than 1 subclass. The concept is this. But every member of the subclass should belong to the superclass, and it's not necessary that superclass members they belong to some of the subclasses. They may, that is optional. But then second thing is, we can have some members which may be overlapping among the subclasses. So it's not necessary that every entity in a superclass be a member of some subclass. So let's see next concept, that is a specialization. So this superclass subclass concept leads to the specialization concept. Here what we have is, we have employee as a superclass. So job type, based upon the type of work they are doing in an organization, we have is the specialization. So a person who is a secretary would be specialized in certain features or would be having some special attributes. So typing speed is the special attribute of this particular job profile. Likewise, if a person is a technician, so technicians in an organization, they are having certain technician grades. They may be having certain courses they have done. Based upon that, they are having the technician grade. Then engineer type, different engineers may be there in the organization. There may be, for likewise nowadays we may be having some software engineers in an organization. Then technical engineers we have, then mechanical engineers, likewise we have electrical engineers. So in an organization, for say it's a manufacturing unit, there may be different engineers working at different levels. So here secretary, technician and engineer, these are the specializations. Then attribute inheritance in the superclass subclass relationship. An entity that is a member of a subclass, first thing, it would inherit all the attributes of the entity as a member of the superclass. But obvious, the superclass attributes also belongs to the subclass member. All the relationships of the entity as a member of the superclass. So here, if a person is a secretary and it's an employee, then all these attributes, name, SSN, birth date, address, job type, all these would also be the attributes of the specialization or the subclass, that is the secretary, technician and the engineer. So example, in the previous slide, secretary as well as technician and engineers, they inherit all the attributes, name, SSN from the employee superclass. Every secretary entity will have values for the inherited attribute. So if an entity belongs as a secretary, would also have all the values for the inherited attributes. So we can say, let's see the formal definition for the specialization, which is very important concept to understand. Specialization is a process of defining a set of subclasses of a superclass. So the set of subclass is based upon some distinguishing characteristic. That is, if we are doing the specialization, as the word tells itself, that there must be certain special attributes or there must be certain specialization or distinguishing features of the entities that we can subgroup them, of the entities in the superclass. Just now, as we have seen, that these subclasses are specialization of an employee based upon the job profile. So likewise, we may have several specializations of the same superclass. Another specialization example, like we have seen in the EER diagram, that is, an employee can be based upon the method of payment, that is salaried employee or a hourly employee. Then superclass, subclass relationship and specialization may be, we can show them diagrammatically represented in the EER diagrams. Attributes of a subclass are called specific or the local attribute. That is, if a secretary has a typing speed, now this is a local attribute of this particular subclass because it does not belong to any of other subclasses. The subclass can also participate in specific relationship types. For example, a relationship belongs to of the hourly employee. That is, a person can belong to like of the hourly employee. If a person is an hourly employee, they can belong to the trade union. Now let's see the generalization. It's just the reverse of the specialization process. That is, several classes at the subclass level, they merge together, they have certain common features, are generalized into superclass. Original class becomes its subclass. For example, we have car, truck, generalized into vehicle. Both car, truck become subclasses of the superclass vehicle. We can view car, truck as a specialization of vehicle, and further we can say it's a reversal. In the reversal we have is car and truck and then generalized into vehicle. Alternatively, we can view vehicle as a generalization of car and truck. Here is an example. we have two entity type or subclasses, car and truck. They have their own specialized attributes: license plate number, vehicle ID, max speed, number of passengers, price. Then truck have price, license plate number, vehicle ID, tonnage, number of axles. Here you can see we have underlined this attribute. So these are the attributes that would be the key. So here license plate number or vehicle ID, any of these two can be the key. Both are the candidate keys. Out of this we can designate one to be the primary key while we are designing the relations. So here also the vehicle ID and the license plate, these are the two candidate keys. So we can see that there are certain attributes which belong to both car and truck. Like we have vehicle ID, license plate and price. These three attributes are common. So what we can do is we can take car and truck as having the specialized attributes max speed, number of passengers, and here truck having number of axles and tonnage as the specialized features or attributes. Then we can merge them into a superclass, that is the vehicle, and it would have the remaining three. The common attributes can be given over here, that is the vehicle ID, price and the license plate number. So this is called generalization. So generalization is bottom up. This is generalization. Students make a lot of mistake in this. Just remember that, and specialization is top down. So diagrammatically, how we can show the notations used to distinguish between generalization and specialization. Arrow pointing to the generalized superclass represents a generalization, that is bottom to top. If we have going arrow, then we can say this is generalization, like this. If we are showing, then this would be the generalization. And arrow pointing to the specialized subclasses, if we are giving from top to down, that represents the specialization. But now because both are reverse process, so sometimes there may be like we are not using this arrow pointing, we simply show this through the lines. Is often subjective as to which process is more appropriate for a particular situation. So we can advocate not drawing any arrows. Now the recent convention is it's not necessary that we show through the pointed arrows. Now very important concept, that is the constraints that can be applied on the specialization and generalization. If all the subclasses in a specialization have membership condition on same attributes of the superclass, specialization is called an attribute defined specialization. That is, all the subclasses in the specialization have membership condition. That is, we have on the same attribute, there is certain similar attribute based upon which we have the specialization. Then we say it is a attribute defined specialization. Like here in this case, attribute is called the defining attribute of the specialization. Like we have seen in the employee and the subclasses, that is job type is the defining attribute of the specialization. Secretary, technician, engineer of the employee. And if no condition determines membership, then the subclass is called user defined. Okay. If attribute based, then it is called attribute defined. And if no condition is there on the attribute and user wants to create a superclass subclass concept, then it is said to be the user defined. A membership in a subclass is determined by the database users by applying an operation to add an entity to the subclass. Membership in the subclass is specified individually for each entity in the superclass by the users. So here is a display of the attribute defined specialization in the EER. We can see here if we have is a attribute base, we have to write the common attribute over here along this particular line. So do remember this, that employee, superclass, secretary, technician, engineer, all these subclasses are based upon a attribute, that is a job type. So the same attribute need to be written over this line. Labeling is to be done here. Now this job type is, if secretary, we are giving the value, then the subclass is secretary. If it is technician, within single quotes we have to give, then it is technician. Engineer job type, then we have made the subclass engineer. These are specific to this subclasses. Now the constraints on the specialization and generalization. Two basic constraints can apply to specialization, generalization. One is the disjoint constraint and other is the completeness constraint. We will see now what is disjoint and completeness constraint. Now disjoint constraint, it specifies that the subclasses of the specialization must be disjoint. What do we mean by this? That is, an entity can be a member of at most one of the subclasses of the specialization. For say, I give you a very simple example. We have a superclass A at the up level and we have, for say, 3 subclasses, that is B, C and D. We know any member belonging to B, C, D would definitely be the member of the superclass A. Now here disjoint constraint is saying that members belonging to the class B intersection member belonging to class C intersection member belonging to class D, it should be null. That is, we cannot have any common members in the subclasses. So how we represent this disjoint? We specify the D. We show it through a alphabet D in the EER diagram. So if not disjoint, the reverse is specialization is called to be overlapping. That is, the same entity may be a member of more than one subclass of the specialization. That is, we may have common members in the subclasses. So it is represented using O letter O in the EER diagram. That is showing the overlapping. Now here you have seen this particular D. This D represents the disjoint. That is, if employee is being subcategorized into this, so there would be no member that would be secretary as well as engineer as well as the technician. So this would be having the disjoint members. Now second constraint is the completeness constraint. Completeness is also called total constraint. Total specifies that every entity in the superclass must be a member of some subclass in the specialization generalization. That is, if we have class A at the superclass level and we have subclasses B and C, then every member of A should be the member of B or member of C for all the members of A. This is the condition. That is, there should be completeness over here. So it is shown using double line. So here we have is the double line. If going from A to its subclasses, then we know that every member of A would be the member of some of its subclasses B or C. Partial allows an entity not to belong to any of the subclass. That is, in this particular case, reverse of completeness is partial. That is, there may be certain employee members which may not belong to either B or C. So it is shown using single line. So if we do the combination of these constants, based upon that, very important that we have 4 types of specialization generalization. First is the disjoint total, that is the members of the superclass, they are specialized in the subclasses, they do not overlap. And total. Disjoint partial, that is there are certain members, they are disjoint, but some of the members of the superclass does not belong to the subclass. Overlapping total, that is we may have certain members that may be belonging to more than one subclass, plus total, that all the members of the superclass belong to some of its subclasses. Overlapping partial, that means we have certain members which belong to more than one subclass, and there are certain members in the superclass which does not belong to the subclass. So generalization usually basically is total, because the superclass is derived from the subclasses. But specialization may not be always total. So here we have seen the D represents the disjoint, and it is partial too because single line is there. So some of the employee members may not be belonging to this. It may be like some members are managers also in an organization. So example of overlapping here we have is at the upper level, at the superclass level, we have the class part, and subclass we have manufactured parts and the purchased part. So see, manufactured parts which are manufactured in the unit itself, and purchased which are purchased from outside. So there may be certain members which belong to both of these subclasses, and that's why we have shown it using overlapping. And all the parts would be belonging to some of the subclasses. It can be either manufactured or purchased. So we have shown it using double line. Then specialization, generalization, hierarchies, lattice and shared class subclasses. So a subclass may itself have further subclasses specified on it. That is, they form a hierarchy or a lattice. Hierarchy is the single inheritance is also said to be the hierarchy. That is, it is also called the tree structure. Has a constant that every subclass has only one superclass. That is, if we have this concept, B and C are the subclasses, and they belong to a single superclass A, so this is single inheritance. That is, B and C, they inherit the properties, that is attributes, and the relationships from a single class, that is A. So single inheritance. Single inheritance is said to be the hierarchy. So in a lattice, a subclass can be a subclass of more than one superclass. This is multiple inheritance. For example, we have a subclass B and it inherit the properties of, for say, two superclasses X, Y, coming from two superclasses. So here B would be having attributes of X as well as Y, relationships also from X as well as Y. So this is multiple inheritance. Shared subclasses, like shared subclasses, here we can see this particular subclass. This is being shared. That is, it is a engineering manager would be an engineer as well as manager as well as salaried employee. So these are the three superclasses, and this is a subclass. It would have the features of all the three superclasses. Then in a lattice or hierarchy, a subclass inherits attributes not only of its direct superclass, just remember this, but also all of its predecessor superclasses. That is, for say we have at the level, bottom level C, then it's just immediate superclasses B, and above it we have a superclass that is A. So C would inherit properties of B as well as properties of A. So all the attributes as well as relationships of A and B would be inherited by C. A superclass with more than one superclass is called a shared superclass, that we have seen in the diagram, that is the multiple inheritance. Can have specialization, hierarchies or lattice. Further, we can make a lot of hierarchies. Likewise, generalization, hierarchies or lattice can be there depending upon how they are derived. We just use specialization to stand for the end result of either specialization or generalization. So, in the specialization, start with an entity type and then define the subclasses of the entity type by successive specialization. So, if we summarize specialization, it's a top-down conceptual refinement process. In generalization, we start with many entity types and generalized into those having common properties. So, it's we summarize it, then it would be a bottom-up conceptual synthesis process. So, in practice, a combination of both processes is usually employed. So, here is a generalization specialization lattice for the university. That is, at the top level, we have the person. Then the person can be in a university employee, can be the alumni, can be the student. Then employee can be further subclasses, staff, faculty. Then we can have student assistants. Then students can be, see, therefore say a person is doing PhD, they can be the student as well as they can be the assistant, faculty assistant. So the category is the student assistant, and you can see they are having the properties of both employee as well as student. They are getting the salary also. Then student can be specialized into graduate students and undergraduate students. Then student assistants, they may be on the research assistant, yeah, teaching assistants. That is, there may be certain people who are just doing the research work, and others they may be as well as doing the teaching assistant. So if we have overlapping members, now over here, we know we show them using double. So disjoint is the this and this members cannot be common, and but all student assistants would be categorized into either of these two. Now, very important concept, this is something different from the multiple inheritance, that is the category or the union type. All of the superclass, subclass relationships we have seen thus far have a single superclass. We have seen. A shared subclass is a subclass in which more than one distinct superclass, subclass relationship was being shown. So, each relationship has a single superclass. Shared subclasses leads to multiple inheritance. In some cases, we need to model a single superclass, subclass relationship with more than one superclass. Okay, here we are talking about the relationship. So here the superclass can represent different entity types. Such a subclass is called a category or the union type. Let's see through an example also. For example, in a database for the vehicle registration, a vehicle owner can be a person, a bank holding a lien on the vehicle, or a company. So a category, how we will show this kind of relationship? This would be a category or the union type called the owner is created to represent a subset of the union of these three superclasses, that is a company, bank and the person. So a category member must exist in at least one of its superclasses. It is different from the shared subclass, which is a subset of the intersection of its superclasses. Shared subclass members must exist in all of its superclasses. Let's show you through the diagram. Here we have this is a owner, is a superclass. So here owner can be the person if it is paying all the installments for the car. It can be the bank if we have taken the loan for the vehicle from the bank. A company if we are taking still the company is the owner unless and until we are paying all the installments to the company. So owner, here owner is a subclass, but it is a union of person, bank, company. Okay, that means this owner would belong to either of these. Whereas in the multiple inheritance, the subclass member would be the member of all the superclasses. Here it's not necessary कि owner would be the member of all. It would be the member of any of these. So this is called the union type. So here owner is the having a union type shown using U. Then they own a registered vehicle which is further categorized into car and truck. Now last important topic, that is the aggregation in this, that is it's a process in which a single entity alone is not able to make any sense in a relationship. So the relationship of two entities act as one entity. So let's see through an example. Here we can see that a manager is a person that would be managing both employee and project. But we cannot have a relationship like this. We have manager and we create a different relationship, that is manages employee and manages project. Now this does not make any sense. Instead what we can do is we create a relationship, that is employee works on the project. This is one, take this to be entire to be one entity type, that is people work on some project and this together is managed by the manager. So this is called aggregation, where a relationship we have taken as to be the entity type among two entity types. So in real world we know that a manager not only manages the employee working under them but has to manage projects as well. So here employee works on project, this is taken as one entity. This is called aggregation. Thank you so much.